Look around you. Ice in a drink, water in a glass, steam rising from a kettle. That's the same substance, water, in three completely different forms: solid, liquid, and gas. Chemists call these the three states of matter, and by the end of this lecture, you'll be able to explain exactly why the same substance can look and behave so differently. In a solid, like an ice cube, a bar of metal, or a grain of table salt, the particles are packed tightly together in a fixed, orderly pattern. They vibrate on the spot, but they don't have enough energy to move past each other, which is why solids have both a fixed shape and a fixed volume. You can drop an ice cube and it keeps its form right up until it starts to melt. Pour that same water into a glass, a bottle, or a bowl, and it flows to fill the bottom of whatever it's poured into. In a liquid, particles are still close together, but they have enough energy to slide past one another. So liquids take the shape of their container while keeping a fixed volume, which is why 100 milliliters of juice looks different in a tall glass than in a wide bowl, but it's still exactly 100 milliliters. Open a bottle of perfume on one side of a room, or let a kettle boil dry, and soon you can smell it or see steam everywhere. In a gas, particles are spread far apart and shoot around freely in every direction at high speed, colliding with each other and the walls of their container. That's why gases don't have a fixed shape or volume at all. They simply expand to fill whatever space is available, whether that's a small balloon or an entire room. Leave that ice cube on the counter on a warm day, and it melts into a puddle as the particles absorb heat energy and break free of their fixed positions in the solid structure. Put that puddle of water back in the freezer, and it locks solid again as the particles lose energy and slot back into a fixed pattern. This back and forth between melting and freezing happens at exactly the same temperature, 0 degrees Celsius for water, which chemists call the melting point. A puddle left on a hot pavement slowly disappears through evaporation, as particles at the surface gain enough energy to escape into the air as gas, even though the puddle never actually boils. And that's also why a cold glass of juice fogs up on a humid day. Water vapor in the warm air loses energy when it touches the cold glass and condenses back into tiny liquid droplets on the outside. Evaporation and condensation are exact opposites of each other, just like melting and freezing. So, the very same particles, just arranged and moving differently, give us all three states: solids, liquids, and gases. That single idea explains everything from why ice cubes cool your drink, to why your kitchen fills with steam when you cook, to why clouds form in the sky above you. Subscribe to Virtual City School so you don't miss Lecture 2, where we'll dig into what actually happens to those particles during a chemical reaction.